Welcome to this Masterclass Explainer. Today, we are cracking the code on one of the most notoriously tricky sections of the Cambridge Computer Science syllabus: hardware management, input-output, and peripherals. Specifically, we're targeting syllabus 9618, but listen closely, because the core exam strategies we are about to unpack are absolutely vital whether you're sitting for 0417, 0478, 0983, 0984, or 2210. Think of this explainer as the ultimate MasterChef recipe for Cambridge success. When you're in that exam room, you aren't just regurgitating facts. You are a chef. Your raw knowledge, the definitions of buffers, interrupts, and direct memory access, those are just your raw ingredients. Your analysis of the exam prompt, that's the cooking process. And your final evaluation, the way you structure your answer, that is the plating. It doesn't matter if you have the finest ingredients in the world. If you don't cook them properly and plate them beautifully for the examiner, you aren't getting that Michelin star, or in this case, the A-star grade. Today, we are going to look at exactly how the examiners expect you to take these raw hardware concepts, apply them to incredibly complex, unseen scenarios, and secure maximum marks. If you've ever felt like you completely understand the hardware, but your grades just don't reflect that knowledge, you are exactly where you need to be. Let's get cooking. Here is our MasterChef agenda for today's playbook. We are moving from the core principles straight through to the exact procedural frameworks you need. First, we'll tackle the challenge, looking at exactly why this topic breaks so many students. Then, we'll cover the core principles of cognitive assessment. Third, we'll dive deep into the procedural framework, where I'll reveal a specific structuring secret. Fourth, we'll look at algorithm evaluation, which is where you secure your top-tier marks. And finally, we will wrap up with critical examiner warnings, the trapdoors you absolutely must avoid. Section 1, the Hardware Management Challenge. Let's set the stage with a real high-stakes scenario. Picture a real Cambridge Computer Science past paper question. Let's say it's asking you to explain how an operating system handles a sudden, unexpected disconnect from a high-speed peripheral during a massive data transfer. I want to introduce you to two types of students we see every single year. First, we have Alex. Now, Alex is incredibly smart. Alex has memorized the entire textbook. When faced with this question, Alex goes into overdrive, completely overloading the answer page with raw computer science facts. Alex writes down every single thing there is to know about buffers and I/O controllers, but provides absolutely zero contextual analysis. It's just a data dump. Then we have Sam. Sam knows the material too, but Sam panics against the clock. Sam rushes in, completely misses the specific command word in the prompt, like evaluate or analyze, and just writes a superficial summary of what a peripheral is. When the examiner's red pen comes out, both Alex and Sam lose massive marks. Why? Because they fail to understand the true challenge of the exam. This quote directly from the principal examiner reports perfectly illustrates the Alex and Sam situation. Examiners report year after year that hardware management is one of the most misunderstood areas. But it's not because the hardware itself is impossibly complex. It's misunderstood because students treat it like a vocabulary test. Rote memorization is the fastest way to fail this section. Examiners don't want you to just tell them what an interrupt service routine is. They want you to explain exactly how and why that interrupt service routine behaves in the highly specific, incredibly stressed system they've designed for that specific question. Alex threw raw ingredients at the examiner. Sam barely cooked the meal. Neither of them demonstrated the connected conceptual understanding required to actually solve the problem. To truly understand what went wrong, we have to look at how Cambridge actually grades you. On one side of the slide, we have the foundational knowledge and understanding cognitive domain. This is your baseline. This is knowing what a potato is in our kitchen analogy. It's defining an I/O controller. But look at the other side, the higher order critical analysis and application domains. This is where the real marks live. This is where you use systematic reasoning to solve complex problems. It's the difference between stating what an I/O controller does versus analyzing exactly why a specific I/O controller setup is causing a major system bottleneck in the exam prompt. Examiners are actively hunting for this higher order thinking. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, now that you're subscribed, let's talk about the exact strategy you need to cross over from basic knowledge to high-level critical analysis. Section 2, the procedural framework. It is time to reveal the strategy. Let's move to the execution phase and look at the concrete step-by-step how-to for tackling these complex past paper problems. This standardized 5-step sequence is your absolute survival guide. It forces you to systematically analyze the evidence before you even think about picking up your pen to write the final answer. But I want to supercharge this by layering it with the ultimate computer science success blueprint, the PEEL framework. That stands for point, evidence, explanation, and link. Let's look at how top students transform their answers. Step 1 and 2 here, deconstruct the question and extract relevant data. That is your point and evidence. Instead of skimming, you actively pull out the exact buffer size or device priority mentioned in the prompt. Steps 3 and 4, select analytical framework and execute. That is your explanation. You break the hardware interaction into its logical phases. And step 5, present with correct terminology. That's your link. Instead of casually writing "the computer stops what it's doing," you explicitly use terms like context switching to link perfectly back to the syllabus. Imagine Alex taking that messy fact dump answer and running it through this system. Suddenly, those red pen marks transform into green check marks. Alex makes a clear point about the interrupt, provides evidence from the scenario, explains the data transfer rate, and links it back to the overall system performance. It's a total grade transformation.
Now, when we zoom out to practical application, these steps help you outline the logical sequence of operations along this timeline. In hardware management, you might not be writing Python code from scratch, but you absolutely are designing logical algorithms for how a CPU interacts with external devices. For example, conceptualizing how a CPU handles a hardware interrupt from a keyboard. You have to map out the initial design of the process, mentally implement the logical steps the processor takes to halt current execution, test that sequence for logical errors in your head, and then evaluate how efficiently it performs. This timeline is your cooking process. You're taking the raw data from the prompt, processing it step by step, and preparing it for the final evaluation stage. And speaking of evaluation,
Section 3, Evaluating Algorithm Quality. This is the plating phase. This is where you prove to the examiner that you don't just know how the system works, but you know how well it works. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's jump straight into our interactive workshop to test your evaluation skills.
Top-scoring candidates always use evidence to justify their decisions by weighing these specific variables. Welcome to the interactive workshop. I'm going to give you 3 rapid-fire challenges right now. Challenge 1, data scan. Imagine a complex data table on your screen, showing an interrupt service routine timeline. You have 60 seconds. What is the core trend? Boom. Time starts now. Are you looking at the time complexity? Are you seeing how latency increases when multiple peripherals pull the CPU simultaneously? You need to be able to extract that trend instantly. Challenge 2, find the flaw. Listen to this sample paragraph from Sam. The buffer stores the data from the printer so the CPU can do other things. If the buffer is small, it doesn't matter because the CPU is fast. What is the flaw? You have 30 seconds. Time's up. The flaw is completely ignoring edge cases and space complexity. A small buffer leads to buffer overflow, dropping data packets entirely, causing catastrophic failure. Sam lost all the marks there for not evaluating the trade-offs and limitations. So that brings us to challenge 3, speed writing. Based on everything we just covered, where do students lose the most marks? I'm giving you 30 seconds right now to mentally write one perfect Peel paragraph answering this question. Clock is ticking. Think about your point. What's your evidence? How do you explain the failure? And link it back to the command word. And time. If your mental paragraph focused on the failure to analyze specific system constraints rather than just defining hardware components, you are right on the money. Let's pivot directly into the insider alerts to make sure you never make these mistakes.
Section 4, top examiner warnings and the method strategy. Let's crack open the principal examiner reports and reveal the definitive system for Cambridge success.
Here are the 3 traps that will instantly sink your grade and the 3 rules that guarantee top marks. Trap 1. Using the wrong formula or algorithm for the context. For instance, confusing the roles of a device driver and an I/O controller. Rule 1 to fix this. Command word decoding. Always underline the command word.
If it says compare, you must contrast two things, not just describe one. Trap 2. Forgetting boundary conditions and edge cases. Rule 2 to fix this. Peel framework application. Always force yourself to write an explanation sentence that explores what happens when the system is pushed to its absolute limit. Trap 3. Providing generic, non-specific answers. This is the most common mistake. Rule 3 to fix this. The time management matrix. Allocate your time based on the marks available. If it's an 8-mark evaluation question, do not spend 6 minutes writing generic definitions. Spend that time analyzing the unique context of the prompt. If you take away absolutely nothing else from this explainer, engrave this method mark strategy into your mind. Even if your final answer is wrong, even if you completely miscalculate the data transfer speed or misidentify the final state of the CPU, method marks can literally save your grade. Always, always show you're working. For hardware management, this isn't always about math. It's about showing your logical sequence. If you have a 6-mark question explaining an I/O process and you accidentally skip step 4, but steps 1, 2, 3, 5, and 6 are clearly laid out in a logical step-by-step format, examiners can still award you 5 out of 6 marks. Your overall sequence was systematic. Use bullet points. Make your logical steps so blazingly obvious that the examiner has no choice but to give you the points. Do not hide your brilliant cooking techniques from the judge.
As we wrap up this masterclass, I'm leaving you with a final challenge to lock this into your memory. What unique acronym will you create right now to remember the steps of an interrupt service routine or the components of an I/O subsystem? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.